So before we talk about equations, the first thing on this page is a bunch of mistakes that people make all the time. And so I'm trying to head those off before you make them. So things on the left are true. Those are true properties. And things on the right are not true. Okay, so that's why there's an X through the equal sign. It's saying that those things are not equal. Do not do those things on the right. So for example, the first one saying this is the distributive property of exponents, which we learned in the first section. We can distribute exponents when things are being multiplied. If things are being added inside a parenthesis, we cannot distribute that exponent. That's something that I already talked about during that section. Similarly with radicals. If things are being multiplied inside a radical, you can break it up. If things are being added inside the radical, you cannot break up the radical. Same thing with things being multiplied. Fractions that are being multiplied, you just go ahead and multiply straight across, but not when they're being added. When fractions are being added, you cannot add them straight across, right? You need a common denominator. And so this is just a reference for you in case you want to try to do one of those things. You might want to come back here and see if it's on this list. But the point of this is that it's just a reference for common mistakes. And if I had to say the common thing here, the common theme, is that addition or subtraction screws everything up, right? Everything on the right here is you can't do because there's addition in between the terms, right? And so the lesson I'm trying to hopefully you take away here is that addition messes up many cancellation properties. Cancellation or distribution, I guess. So be careful about that. These are common mistakes. Try not to make them. Didn't want any clarification on any of those? Okay. Let's talk about equations then. So there's two types of equations that we'll see for the most part and that we want to try to solve in this class. Linear equations and quadratic equations. So linear equations have this form, ax plus b equals something, where both a and b are real numbers. So this symbol, this capital R symbol, means a real number. And so lines, when we think about things that look like that equation, are straight lines. So if we had an equation like that, it's going to look like this. It's going to be straight. Quadratic equations have the form ax squared plus bx plus c. And so this is more like what we've been practicing factoring, right? So quadratic equations are what we were working on in the last section, factoring. And these things look like, they have like a U shape. They kind of look like this. Sometimes they're pointing up, sometimes they're pointing down, but they generally have some sort of U, curved U shape. And when I'm talking about solving equations, what we're talking about here is isolating the variable, right? So isolating the variable on one side of the equal sign. We want to know what x equals, right? That's what I mean by solving equations here. And so generally speaking, the general method for solving equations is we reverse the order of operations, right? So for example, instead of multiplying and dividing first and then adding things later, we would want to get rid of addition and then get rid of multiplication. So we like undo the order of operations in some sense, right? And the key thing that I'll remind you that we've already mentioned a few times, both sides of the equal sign. Don't forget to do that or else you'll be changing the problem. Before we get started, I want to remind you of these key facts here. This is another thing that people often get confused. If we have the square root of something equals something else, then that means that whatever is underneath the radical equals the other thing squared, right? So for example, I know I'm saying thing a lot. If we had like square root of x equals 4, then that means that x equals 4 squared, which is 16, right? That's what this property is telling us. But we only get one answer is what I'm trying to point out here. If we have something under a radical and we want to solve that equation, we just square both sides. We like put a square on both sides. It gets rid of the radical and we get a single answer. But I want to remind you, if we start out with something that looks like this, then we solve this by taking a square root, and when we take a square root, we get two answers. We get a plus answer or a minus answer. For example, if we have something that looks like 16 equals y squared, and we want to solve that, then we take a square root, right? We write square root over both those things, and we end up with y equals plus or minus square root of 16, which is plus or minus 4. Right? So just reminding you that if you actually go ahead and take a square root, you get two answers. Right? So this would be y equals 4 and, not or, I guess, and y equals minus 4. So you get two answers in that situation. Right? Really, really want to remind you that. Can't stress it enough. I'm going to point out where the plus and minus is and just write down. We get two answers when we physically take a square root. That's the takeaway of this. That's what I'm trying to remind you of. So if you have an equation and you take a square root, you get two answers. I've said that many times now, but I'll probably say it again. So let's look at a linear equation first. Linear equations are the nice ones. So to solve a linear equation, you get all the variables on one side of the equal sign and all the numbers on the other side of the equal sign, and then you multiply or divide as needed to isolate the variable. And so something tells me folks can probably do this one themselves. And so I'd like to ask you to try that, and I'll just start it, right? So I'm going to get all the variables on one side. So I'm going to add 4x to both sides so that it cancels on the right and I get 6x on the left. I'm just going to go ahead and finish this one. I feel like we've spent a lot of time today on other things, so I'm going to finish this one. Right, now I want to get rid of the 8, and so I just subtract the 8 from both sides so that it cancels on the left. And then on the right, I'll get a minus 2. 6 minus 8, right? And now this is good because I've got the variables on one side and the not variables on the other, the numbers on the other. And to isolate this x, I want to undo multiplication. So I've got 6 times x. And so to undo a multiplication, I want to divide. And so you divide by 6. And you get x equals minus 2 over 6. Or minus 1/3, if you will. I just wanted to quickly remind you about solving those linear equations. Are there any questions about that one? Do you guys remember how to do those? I think focusing on the quadratics is probably the better thing to do. But I'm happy to sort of clarify anything if you have something. You might just need a little practice. If you haven't looked at this stuff in a while, you might just need a little practice with it. Let's focus in on quadratics. So quadratics, quadratic equations, i.e. These are equations with x squared, that's what that means. So quadratic equation, so when you hear the word quadratic, you just think x squared. Quadratic means there's an x squared. Okay, there's two methods for doing these ones. You can either take the square root of something. If it's a nice enough equation, you might just be able to isolate the variable and take a square root. And when we take a square root, we're going to want to remember this property, right? We want to remember when we take a square root, we get plus or minus. Or we can use the quadratic formula. Right, so we're going to see these on the next page. So let's turn the page and take a look at the first example. And so these are numbered 1 and 2, right? And so you'll see on the next page there's a section 1 and there's a section 2. And actually, there's a 1 in a section 3 for some reason. So gotta change that. So the first method is taking the square root. And it only works if it's as I mentioned, if it's kind of like a nice equation. If the equation isn't too nasty, then we can just isolate the variable and take a square root. For example, on this first one, we have y squared equals 81. That's about as nice as a quadratic equation can get. We want to use that property from the previous page, right? This is literally this property, almost verbatim. It's this property, but there's an 81 there. And so when we take a square root, we're going to get two answers. Right, so we want to get rid of the squared. To get rid of the squared, we write square root. And then it cancels out the square on the left, but we end up with a plus or minus on the right. So we get plus or minus square root of 81, which is plus or minus 9. So the answer is y equals 9, or it equals minus 9. Is everyone okay? Okay, very rarely are you going to have one as nice as that. I just want to illustrate that property, right? Sometimes you get ones that are more like on the right, where you have something that's being squared. The only thing on the left-hand side is the whole thing is being squared, and then just numbers on the right. And so this applies to this first method here, because if we take a square root of the left-hand side and the right-hand side, the square root is going to cancel out that squared again. And we can do this because the whole left-hand side is being squared. Right? If there was something else there, we wouldn't be able to do this. But because it's the whole thing is being squared, we can take a square root, and it drops that squared, right? And we'll end up with y plus 4 on the left. And then we get plus or minus square root of 10 on the right. And you know, 10's not a perfect square, and so we're just going to leave it as square root of 10. But we do get two answers there. Now, we're not quite done because we don't know what y is. We know what y plus 4 is. Y plus 4 is plus or minus square root of 10, but we want to know what y is, right? And so let's isolate y by subtracting the 4. And so we get y equals minus 4 plus or minus square root of 10. And so that's a good answer. Just to be clear, it's two answers. So sometimes you have to, just let me show you how to enter this in WebWork if you need to. So on a homework, or on a test or a quiz or something, minus 4 plus or minus 10 is a perfectly great answer. But in WebWork, sometimes it wants you to enter them separately. And so just to be clear about that, this expression, that means that y equals minus 4 minus square root of 10, and y equals minus 4 plus square root of 10. So we get two answers there. And oftentimes, yeah, go ahead.
Why would you distribute that squared inside of, like, why would you do y squared plus 16 and then equal 10?
Yeah, so we don't want to distribute that squared because that's one of the common mistakes that we're trying to avoid. That's literally that first common mistake, right? And it's because that things are not being multiplied. And let me just point out why that's true. At some point I always try to do this anyway. If we had y plus 4 squared, we know that that's this. Right? Whenever you square something, you multiply by itself. And when we multiply this out, when we do the distribution, and we do this whole thing, we would get y squared plus 4y plus 4y plus 16. And so we do get a y squared, and we do get a 16, but when you do it that other way, you miss out on this 8y. Right? So that's why this is not equal to y squared plus 16, because you're missing that middle term when you just distribute that. the other reason, just to be clear, even if that was an okay thing to do, we're trying to solve for y on this one. And so distributing that square, I guess if you could do it, you could then subtract the 16. Is that what you were thinking of doing? Yeah, okay. So yeah, we don't want to do that, because then if we multiplied this out, we'd end up with this whole expression equaling 10, and then that's just going to make it more complicated to solve. Other questions about that one? Does everyone see what I'm saying about these two different numbers? Oh, I was going to add one more thing. Sometimes WebWork wants you to, it gives you two, and you've already discovered this probably. It gives you two places to enter, and it says like, put the smaller one first and the bigger one second, right? So in this expression, you could plug it into your calculator and figure out which one's smaller and bigger, but just looking at it, which one's the smaller one? The first one, right? Why is this one the smaller one? Yeah, so they both have a -4, right? But this one's -4, and then you're subtracting from it, so that's going to be even less than -4. And then this is -4, and you're adding something to it, so that's going to be bigger than -4, right? So just be aware that sometimes you need to order them to enter the answer. Questions about that? All right. I used to do another method. That's why this one's number 3. But then I decided we used to do I forget what other method we used to talk about, but I didn't like it, so I got rid of it. So anyway, this is method 2. And that's a quadratic equation, a quadratic formula. Just realizing now that I probably need to sing this morning, because that's how I always remember the quadratic equation. But anyway, the quadratic formula is nice because you can use it to solve absolutely any quadratic equation. Anything with an x squared, where x squared is the highest value, you can use this formula to solve it. There's just one key thing, which is that you need to have the equation equal to 0. And so if it's not equal to 0, you just need to subtract whatever is over on the right-hand side to the left to make it equal to 0. And I don't know if there's any in the homework like that, but just be aware of that. So given an equation of this form, ax squared plus cx, ax squared plus bx plus c equals 0, the roots of that equation, that's true for x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I know it's like kind of nasty looking, but if you do it a few times, I feel usually it's not too bad to remember. Does anyone have a good way that they remember that one? Does anyone else know the song? Oh, and you want to sing it?
No.
Oh. Does anyone want to sing it? All right, I will sing it one time. It goes to the tune of Pop Goes the Weasel. Right, so all around the mulberry bush, the monkey chased, but except you just replace that with this stuff. And I know it sounds so strange, and I have very distinct memories of sitting in my middle school or maybe high school class and having my teacher sing that, and we all made fun of her and like called her crazy, literally called her crazy. But listen, it's been 15, 16 years, and I remember it still. So that's saying something. And maybe it was because she was so crazy, I don't know. But anyway, I'm going to sing it one time, and hopefully that'll help you, and I encourage you to sing it once or twice, and you'll remember it. All right. So you say, you read the right-hand side. So you go, negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, thank you. So anyway, sing that in the shower one morning, and maybe you'll remember it. I don't know. Maybe you need to have it in front of you the first time. Don't bring your notes into the shower. Anyway, seriously, it's crazy, but I've remembered it all this time just from that song. So it is useful. So anyway, let's do one or two of these. That clock is correct, right? Yeah, okay. So let's look at this one. So this one is kind of tough to solve. I don't know how to solve that. I mean, maybe we can factor it and that might help, but I don't know if I can factor these ones. And the nice thing about the quadratic equation is we don't have to think about factoring. We don't need to do any of that stuff. We just plug stuff in here and we get the answer. And so when I look at this equation, my A is 2. My B is minus 6. Don't forget about the negative sign. And the C is the positive 4. And we can just get the answer right out of here. I think we won't need another example, so I'm going to go ahead and cross out that EX. But our final answer, we would start saying, okay, that means V equals negative B, so negative 6, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. And that'll be the solution. We have to do some simplification. Sometimes it simplifies into nice things, other times it doesn't. This one is going to simplify pretty nicely. But are there any questions on how to plug that stuff in to start? So let's go ahead and simplify this. So this means that V equals 6 plus or minus 36 minus 32 over 4. Is that a question? Or? All right, let's keep going then. So 36 minus 32 is 4. So we'll get 6 plus or minus the square root of 4. That's good because we know what the square root of 4 is. 2, good. So we'll keep on going. So this is 6 plus or minus 2 over 4. Oops. Holler at me if I go off the screen there. I'm still going to go off the screen. I have a real hard time with this thing. There's just not enough room up here. It gets stuck in the corner. Okay. Almost. I'm just going to leave it crooked for a second. I'm sorry. No, I'm not going to do that. Whoever's going to watch this video is going to like throw up when they're watching it. Sorry if you're watching this right now and you're throwing up. Okay. Great. So we get two answers there, right? Because we got the plus or minus. So this means that V equals 6 plus 2 over 4. And so when we do 6 plus 2 over 4, we get 8 divided by 4, which is 2. And V equals 6 minus 2 over 4. And so that'll be 4 over 4, which will give us a 1. Okay. Questions about that one? You guys have seen this before, I'm assuming, at some time or another. Has anyone else heard that song, that song? So you want to sing it? Alright, let's do this last one. I think we've got time for this last one here. And I'd like to actually ask you to try this last one. So we'll spend 5 minutes on this last one, and then we'll do the quiz here. Just to be clear, in this first one, in this last one, A is 1, B is 3, C is negative 12. All right, give that a go. So plug it into the formula, simplify it down as far as you can go. You will get two answers, but it's not going to be a whole number like this last one was. Be aware that the square root is not going to be a perfect square. And so you'll get something that's going to have a square root in your answer, which is okay. There's nothing wrong with that. Did anyone not grab this piece of paper? No, it's not too late, you might not as well. Put this minus, we'll multiply that minus, make it a plus. And also 48. Did you have a question? All right, I'm going to start looking at this one just so we have enough time for the quiz here. So when I start plugging stuff in, so A equals 1, B equals 3, C equals 12. Hopefully that's all right. And when I start plugging things in, I get Y equals negative B plus or minus the square root of B squared minus 4 times A times C. All over 2 times A. And when you start simplifying things down, be aware that in the right-hand side, you've got minus 4, and it's going to multiply by the minus 12. So that's going to create a plus, right? So you'll end up with 9 plus 48 over 2. And so you get minus 3 plus or minus square root of 57 over 2. And on a test, that's a perfectly good answer. Test or quiz, that's great. You know, showing you have the plus or minus is showing me you know there's two answers, and you get two answers. I just want to point out, though, how you can manipulate this and enter it different ways in case you need it on WebWork or some other thing. So this is an okay answer. You could also write y equals minus 3 plus 57, square root of 57 over 2. And minus 3 minus square root of 57 over 2. So that's another way to show that you get two answers, right? I wrote one with the plus sign and one with the minus sign. And then I'll just say one more time, you could also break this up into two different fractions. You could break this up into minus 3 halves plus square root of 57 over 2. And then minus 3 halves minus square root of 57 over 2. Just, you know, I just want to show you how you can manipulate that thing in different ways and present it three different ways. So really, just so that if you see an answer sometime that looks like one of those, you can kind of compare them and know that they're all the same. That's sort of what I'm thinking there. When we want to solve a fraction with an x in the denominator like these, it's challenging because the x is in the denominator for that very reason, right? So we want to get it out of the denominator, which means getting rid of all the fractions. And so the nice, easy way to do that is a two-step method. We first, number one, we multiply everything by the common denominator, whatever that happens to be. And then two, we go ahead, we solve the equation using one of the previous methods on the last page. So if it's a linear equation, it's no big deal. And if it's a quadratic, we can use either the quadratic formula or taking a square root, right, depending on what it looks like. But the first thing we want to do is multiply through by the common denominator. So when we look at this problem, what is the common denominator of those two fractions? Say that a little louder. Yes, x squared minus x, which you got from x times x minus 1, right? You multiplied both those things together. You just take the two individual denominators, and if you multiply them together, since they're distinct, that becomes the common denominator. Is that part okay? I was hoping that wouldn't be too big of a problem, and since it's after the homework. What are the questions about that? Okay, so now, if that's a common denominator, we just multiply everything in the equation by that. And just like in the last section, what happens is all the fractions cancel out, right? So I'm going to do that. I'm going to write out all the steps for that. But we take the first piece, and we multiply it by that common denominator. We take the second piece, we multiply it by the common denominator, and we take the third piece, and we multiply it by the common denominator. I feel like I usually end up running out of room here, so be aware that I've already written things too big, so I'll try to write things a little smaller than that. And so the point of doing that is because the denominators cancel. Right, so the x minus 1's cancel on the left, and we'll be left with an x. The x's cancel on the middle term, and we'll be left with an x minus 1. And then nothing cancels on the right, and we'll multiply that out. We'll send the x through that parenthesis and distribute it. And so we'll end up with x minus 2x. I'll write it like this first. How's that? Equals x squared minus x. And so it's already nicer. It's already not, there's no fractions, right? And it's a quadratic that we can solve using either factoring or taking the square root or using the quadratic formula. And so let's see which one works. So we just want, at this point, we just want to get x by itself. And so let's get all the x's over on one side. And so we'll distribute the 2 through there, and we'll get x minus 2x plus 2 equals x squared minus x. Let's move everything over to one side. Oh, actually, we can combine the x's first. Let's combine this x and this minus 2x. So we'll get x minus 2 is minus x plus 2 equals x squared minus x. And now we'll move everything over to one side. So let me just rewrite this first, actually. Let me do this, and we'll move over here. We'll get minus x plus 2 equals x squared minus x. So we're trying to get everything over to one side. I'm going to move everything over to the right side, just because that's what appeals to me. You can do either way, right? So I'm going to add the x over to both sides. Whoops, plus x. And then I'm going to subtract the 2 from both sides. And so what we'll end up with is everything cancels out on the left. And we get x squared plus 0x minus 2. I just wanted to write the 0x just to be clear that those x's canceled. We got a minus x plus x gives us a 0x. And so it turns out this is a nice enough equation that we don't need the quadratic formula. So now that we're at this point, we see that all we need is we want x squared minus 2 to equal 0. And so that's something that we can solve without the quadratic formula. You're welcome to use the quadratic formula. The quadratic formula will always work if we want to solve something like this, right? Always work. And so if you just like using that and you want to just have one method, that's fine. You can use the quadratic formula on this one. But note that we can just add the 2 over to the other side, right? We can just add the 2 over, see that x squared equals 2, and now this is a problem that's just like one of the easy problems on the last page, right? We can take a square root. We can just take a square root of both sides, and we'll get x equals plus or minus square root of 2. Don't forget about that plus or minus part. It's really important. We get 2 answers because we took a square root. Questions about that one? Who came in late that didn't get one of these pieces of paper? So if you want one, you're going to have to put your hand up high enough so that I can see it. Thank you. Grab one of these guys. Can you slide that down to Anna, please? Emma? Oops, I should grab one too. The questions about this idea? Let's look at this application then. So this is a continuation of the problem from last class. And if you remember last class, what we had that situation where you had two people who were using a computer, one of them, and then they use a Facebook. Sorry, let me start over. Two people who are using the internet, and then within that they use Facebook for some percentage of that time. Remember that problem from last time? And so last time we had this expression that was the ratio of their two Facebook uses, and we multiplied it by 60 over 60, and that simplified it down into a not compound fraction anymore. So that's what we had done last class, and I want to continue it here, because now let's solve this equation, because this is a fraction, right? And we just learned out how to solve fraction equations. And so let's suppose that they spend the same amount of time on Facebook. And so if they spend the same amount of time on Facebook, and the numerator is how much Carlos spends, and the denominator is how much Janine spends, then when we divide those two, it should equal 1 if they spend the same amount of time. And so the question might be, so first of all, that means that their original equation, 32t plus 96 over 55t minus 75 equals 1, again, because they spend the same amount of time on there, so that when you divide the two times, it's 1. And if we want to know how much time Carlos spent on the internet in the first week, so how much did he spend on the internet in the first week? This means solve for t. So we want to solve this equation for t, and it's a fraction, and we now know how to do that. So what should we do? We want it to not be a fraction anymore, right? So how do we do that based on what we just learned? Jeez. I'm sorry? So you want to multiply by, maybe you're right. So what do you want to multiply by? You might be right, just not sure. Say the actual expression. I mean, you're right by that. You want to? Yeah, go ahead. You want to help her?
We want to get rid of denominators, so we multiply 55t minus 7 on both sides.
Yeah, if we want to get rid of the denominator, we multiply by the denominator, so that it'll cancel on the left, right? So if we take this equation, I shouldn't have drawn that arrow so close there. We take that equation and we multiply it by the denominator, it'll cancel out. But if we do that on the left, we've got to do it on the right. Right? Whatever you do to one side of the equation, you've got to do to the other. So don't forget about that. Because then they'll cancel out on the left, and we just get 32t plus 96 equals 55t minus 75. And this is something that we can solve without too much of a problem. Right. So we just get the t's on the same side. So I'm going to do it in just one move here. I'm going to subtract the 32 over to the left, and I'm going to add the 75 over to the right. And we'll get 23t on the right, and then 96 minus 25 is 21. Oh, I'm sorry, I'm adding 75. Thank you. I subtracted it there. So it'll be 171. Does that sound right? And then we want to get t by itself, right? So we just divide the 23 over, and 171 over 23 is how long Carlos spent on the internet during the first week. And I don't have my calculator with me. I'm not sure what that equals. It's probably about 7 hours. Say that out loud. 7.43. Some of you guys probably spend more time on the internet during class than that. Jeez, it's not very much time. Questions? Is that okay? So I would recommend this page going after this current page, right? So this is probably page number 14, or 13B, if you will. I would write 13B on the top of there, throw it in after that last page. All right. Is that okay? Are there any questions about that one? Let's keep on keeping on then. And let's look at solving an equation with a radical. Yeah, so in case you haven't noticed, this section is it's a lot of really small topics, and we just kind of like do one example, because I know it's stuff that you've probably seen before, but maybe need a reminder, so we're just going to like do an example and move on, do an example and move on, and then hopefully when you practice it in the homework, the intention is that's where you're really going to solidify your knowledge of this stuff. Okay, so if we have a radical, so obviously there's a radical in this equation, right? The square root of x plus 1 isn't a radical. If we want to solve for x in this one, we do three things. The first thing is we isolate the radical on one side of the equal sign. The second thing we do is we get rid of the radical by raising both sides of the equation to the same power that will cancel the radical, right? And then 3, we won't have a radical anymore, and you just solve for x using one of the previous methods. If it's a linear equation, no problem. If it's a quadratic, maybe we use the quadratic formula. Okay. So when I'm looking at this problem, step 1 is important because I want to square this equation to get rid of the x squared, to get rid of the square root. But if I square it right now, I have to do a whole bunch of things on the left-hand side that's going to make it a very complicated problem. And so the first thing we want to do is isolate the radical by subtracting the 2x to the other side. So when we get rid of the 2x, we want to do that, again, because now if I square the left-hand side, it just drops the radical. And we'll have to do some work on the right, but we know how to do that work. All right, so the next thing we want to do is to eliminate the radical by squaring both sides. So I'm going to write out the details here. We square the left-hand side, we square out the right-hand side, and this is going to drop the radical on the left. But before we do that, I want to just clarify and make sure everyone's on the same page about the right-hand side. How do we think about doing that right-hand side? This is one of the things I've been mentioning a couple times that people make a common mistake on a lot in this one. What's the right way to think about that one, Manuel? Yeah, we want to think about a product of two polynomials like that, right? We do not want to just send the square through the parentheses, right? We need to do a FOIL thing here, which is more than just squaring all the terms. Really can't stress that enough. I know it's something that that's a very common mistake. Anyway, so then when we do that, the left-hand side just drops to x plus 1. We no longer have a radical on the left. That's good. And then when we square out the right-hand side, when we do that whole FOIL, we'll end up with 4x squared minus 32x plus 64. And let me just say out loud why we don't want to square this, like why we don't just send that 2 through and square those two numbers. If we sent the 2, the square, and we squared the 2x, we'd get this 4x squared, that's fine. And if then we squared the 8, we'd get a 64. And so we get those two values in our answer, but we miss the 32x if we do that. Right? That's why we need to make sure that we FOIL those things. Questions so far? Because now it's just a quadratic problem, right? Now we have a quadratic that we can solve using the quadratic formula or something like that, right? So the next thing is solve the equation. So I'm going to get everything over to one side. I'm going to subtract the 1. I'm going to subtract the x. And when you do that, you get minus 33x plus 63 equals 0. And so now we want to solve that equation. And that looks like a real good candidate for the quadratic formula. Right? It's not going to be a nice factorable thing, so we use the quadratic formula. So I'm going to do that using quad form. And when you do that using the quadratic formula, you get the following. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so these are values that x equals. X equals those things. Right? And just to, yeah, go ahead. 33 is negative, but the quadratic formula uses a negative b. Let me just throw that up there real quick. Right, when we look at the quadratic formula, we negate whatever b is in that first spot. And so if it's positive, it becomes negative, and if it's negative, it becomes positive, right? So this one was negative, it was a negative 33, and so we negate it, and it becomes positive 33. Is that okay? And so I'm just going to write down what this simplifies to, right? There's a bunch of steps where you would have to simplify what's inside the root, etc., etc., and then this is a good one to try on your own maybe. When you simplify it down, you get the number 3, and the number is 21 over 4. And so those are the two roots, the two solutions for this equation. Now there's a very important little point here that I need to make, but I want to make sure everyone's caught up with this and paying attention. Is everyone set? Just wait 1 second here. Yeah.
I have a question. So for the last one, we when it was a value without x, we put it to the other side of the 0, and then we solve for x. Why aren't we doing that here?
I'm not.
Like minus. Okay, so like.
So you're talking about here where we added the 2 over, wherever?
Yeah, exactly. And then down here we just left the 63.
Because if we move the 63 over, we'll still have 2 x's here, and we won't know how to get 1 by itself. So when you have a quadratic that's too complicated, we use the quadratic formula. The one before it was nice enough. It was just one single term with an x and one single term that didn't have an x. And so that let us just add the 2 over and take a square root. If we subtract the 63 over to the other side, then what do? We'll have 4x squared minus 33x. We can't just take a square root to get rid of the square because the 33x is there, and we can't add the 33x over to the other side because then the 33 will also be there, right? So let me just write that out just to be clear about that. We'd end up with, if we subtracted the 63 over, we'd get 4x squared minus 33x equals minus 63, right? And I'm trying to say that there's not a clear thing to do now. Like, what would you think about doing? I don't know. If we take a square root, if we do a square root, that's not helping because we can't pull an x out because this is inside there, right? If we add the 33x over to the other side, now we've got an x on both sides of the equation, and that's not helpful because we want to get it on one side. And so the answer is this one's too complicated to do something simple like this with. And the flip side of that is, if you're confused, like, oh, I don't know which one to do, you can use the quadratic formula on this equation. It's a very simple equation, but you can still use the quadratic formula. A equals 1, C equals minus 2, and B equals 0, right? There's no B in this equation on the quadratic formula. So you could use the quadratic formula, and you would get the same answer. Does that help? Are there other questions about this one? Okay, so there's a really important point that's very important, and it's gonna, if you listen right now, you're gonna save yourself a lot of frustration on the homework. And I would recommend writing this down. Note. Not all answers you get from this method will be correct. And I know that seems very strange. But I'll explain why in a second. So not all the answers you get from this is going to end up being correct. To see what's correct, you have to plug the number back in and see if it's true. So you must plug them back in and check their validity. And I know that sounds really strange because usually, you want to think, well, if I do the right math things and I follow the right properties, then I should get the right answer. And what I'm saying is sometimes you get the wrong answer when you do this method, which seems very counterintuitive. And so, first of all, by these methods, there's two. I mean the one that we just did, and also the first one, occasionally. And so both the two methods on this page, you need to be careful about whether or not what you wrote down is true. And that's because when we square things, or take the square root of things, we end up with artifacts that are not from the original equation. We end up with more terms when we end up squaring something. And so sometimes what comes out is one thing that's true and one thing that's not true. And I wish I could tell you a nice rule like, oh, when there's a positive number in front of the x squared, you get the right answers. And when there's a negative, you get the wrong. It's not that cut and dry. You just have to see, you have to plug the numbers back in and see. And so let me just show you what I mean by that. So just write a line right here. We're going to do these last couple, but we don't need very much room for them. In fact, I may just skip that one. I'm probably going to end up skipping one of them. Anyway, I'm going to just check these values right on the right-hand side here. Or actually, you know what? You could do this on that last page that I just handed out. That last page had a whole bunch of extra room on the bottom of it. Maybe you want to do that. But I'm going to check these two answers here. So I think the solutions to this are x equals 3 and x equals 21 over 4. Let's see if that's true. So x equals 3. I'm going to put a question mark because I'm not quite sure if it's true or not yet. And I'm going to plug it back into the original equation. So I'm going to take this original equation and I'm going to plug a 3 into it and see whether or not it equals 8. And if it does, it's the right answer. And if it doesn't, then it's not. Right, so when I plug a 3 in, I get 2 times 3 plus the square root of 4. That equals 6 plus 2, which is 8. And that's what I wanted it to be. And so 3 is a solution. So true. So x equals 3 is a solution. I'll go ahead and box that one in. I like that one. It's true. But you'll see that when we do the next one, it won't be true. So the other thing I think it is 21 over 4. So let's try that one. X equals 21 over 4, question mark. Well, let's see. When I plug 21 over 4 in, I'll get 2 times 21 over 4, which is 41 over 4. I'm sorry, 42 over 4. And then when I plug a 21 over 4 into x, the square root of x plus 1, I'm just going to simplify it. We end up with square root of 21 over 4. That does not equal 8. You're welcome to try it yourself, but I'm telling you it's not going to equal 8. I mean, for one thing, square root of 21 is not a whole number. And so this is already going to be a decimal. Right? So we know it's going to be some decimal answer. It can't be 8. And so what we just found out is x equals 21 over 4 is not a solution. It came out and we did the math right. We didn't break any mathematical laws or anything. But because we squared that equation, we ended up with an answer that wasn't true. And this in my opinion, I think this is the only time that I ever teach something where it's like, you might end up with something that's not true and you need to be careful. And so I just feel very strange talking about this section. So I'll just say that one more time now, just to be clear. You need to check when you do these two methods, when you see ones in the homework that look like this or look like this, you just need to double check the answers and make sure they're true. Save yourself some trouble, save yourself some frustration, because otherwise you're going to try to enter into WebWork and it's going to say, that's not right. And you're going to think, well, my math must not be right. And your math might be fine. It's just that you didn't double check the answer. Okay? Questions about that? Is that okay? I hope that's not too strange. Yeah. No, that's a good question. One of the answers will always be true, unless there's no solution. But I wouldn't put something on there that didn't have a solution. Yeah, so you will get one correct answer at least out of there. That's a good question. Yeah. Other questions? All right, let's look at this last one then. Like I said, we ran out of room on this one, and we're going to need some more room. So I'm just going to delete this one on the right here. Let's talk about absolute values. Absolute values are interesting. I feel like they're something that you know what they are, but you never actually use them in equations. And so here's this property that's really important. Here's how we solve absolute value equations. If we have the absolute value of something equals a, so absolute value of x equals a, that means whatever's inside there equals a, or it equals the opposite of a, the negative version, right? And then when you take the absolute value, it becomes positive. For example, just a little quick example, if the absolute value of x equals 2, then that means that x equals 2 or negative 2, right? Because either one of those, if you plug a 2 into the absolute value, it would be 2. And if you plug a negative 2 in there, it's also 2, because it becomes positive. And I know that's like the basic definition of an absolute value, but that's how we treat equations inside of absolute value 2. We write down two separate equations. One of them equals whatever's inside of there, the absolute value, and one equals whatever's the negative thing. So for example, on this first one, if we want to know the absolute value of 14 minus x equals 28, we use this property to rewrite the equation as, so use property above to rewrite this as two separate equations. We write it as, we drop the absolute value and we write 14 minus x equals positive 28, or 14 minus x equals negative 28. And so now we can solve the equation. We don't know how to solve things inside of absolute value, so we need to get rid of the absolute value before we go ahead and do that. Does everyone understand that property? And see how I just applied it?
I don't understand like the 28 and then negative 28, because what, didn't you just solve the original equation, just take off the absolute value and then put, and then you know what's absolute value, so you just put the opposite?
Well, that's what this one's going to be. So what I'm saying is, look at the original problem. 14 minus x. If we want the absolute value of 14 minus x equals 28, then whatever's inside that absolute value needs to either be 28, because then it'll stay positive, or whatever's inside that absolute value needs to be negative 28, because then we'll take the absolute value and it'll become positive 28. And so that's what I'm doing here. I'm writing down what's inside there needs to be either positive or negative 28, because when we take the absolute value, it's going to become positive 28. Does that see what I'm saying? So no matter how complicated an expression looks, that's how we do it. We rewrite it, we drop the absolute value, and we rewrite it two different ways. One with the positive, like that, and one with the negative, like that. So is there another hand over there?
So do you leave it at that, or do you add 14 to the 28 so you could get the value of x by itself?
We want to get x by itself, yeah, but we don't want to add 14 at this point. We want to subtract it over, and then we'll switch the sign by doing the negative, yeah. So let's do that. So I'm going to do it in one step, right? So I'm going to, well, there's two ways to think about it. I don't know. You could either add the x over to the other side and subtract the 28, or you could subtract the 14 and do the x. I'm going to do it in one step. So I'm going to subtract the 14. Actually, that's not what I wanted to do. I wanted to subtract the 28. Yeah. I want a little bit of room at the bottom so I have enough room to check. So I'm going to try to do it like this instead. Let's subtract the 28 and add the x. So we'll add the x and add the 28 on the right. I'm just trying to get everything, I'm trying to get the x by itself without, and just in one step. So when you do that, you get x equals minus 14 or x equals 42. And so these are our two possible answers. And we can check, and I'd like to check just quick. So let's check to see if those are true. This is another one you usually want to check with. I believe you can get wrong answers sometimes out of these. So 14, if I plug a minus 14 in, we'll get minus, I wrote my parenthesis too soon. We get minus x. So 14, I just did it again. I forgot to plug in the number. Having a hard time with this. So if I plug in a minus 14, we get 14 minus 14. My goodness. And so the double minus turns into a plus, right? And we get the absolute value of 28, which is 28. So that's good. So 14 works. Negative 14, excuse me. And if we plug in a 42, we'll get 14 minus 42. That equals the absolute value of negative 28, which becomes positive and gives us positive 28. So that one worked as well. So both of those are good solutions.